Hey math enthusiast, I'm here to go over the notes from section 1.4, which deals with measuring and classifying angles. First thing we want to do in this section is define exactly what an angle is. Well, the first thing I need to know is that it's made up of two different rays. Okay, so remember rays have one endpoint, they continue on in one direction forever. So it's made up of two different rays, and those rays share an endpoint. So they have the same endpoint. And we'll see that in the picture below in a second. Now, the rays that make up the angle, those rays are the sides of the angle. And the endpoint that they share, that is known as the vertex. So the vertex is the endpoint that they share. That's essentially where the angle grows from. So using those definitions, let's take a look at the example below. First thing they want us to do is name the sides in this angle. So remember, the sides are the rays that make up the angle. So the first one I could say would be ray RJ. Remember, when you're naming it, you start with the endpoint and use that symbol for ray, always pointing to the right. The other ray would obviously be RM. Remember, they share the same endpoint. In this case, that endpoint is also the vertex. So in this case, the vertex is just point R. And we can just name that with a capital R. Now, as far as names of the angle go, first thing I need to include is the symbol for angle. So it's just a small little symbol like this, just to show that I am referring to an angle. Now, in this case, I could simply call it angle R, named after the vertex, because there's really only one angle in this picture. There's no confusion. I know I'm referring to this angle right here. Another option is, if you want to be more specific, is I can use the other 2 points inside my angle. So I could call it angle JRM. Notice that I put R in the middle because R is the vertex. The other option would be to just go in reverse. You could name it angle MRJ. Using 3 letters will work a little bit better in case there are other angles coming off of point R like this. Alright, in this case I can no longer call it point R because now I'm not sure if I'm referring to this angle, if I'm referring to this angle below it, or if I'm referring to the large angle that contains both of these. Now, in the next example, there's a little bit more going on in this picture. First question wants us to list all the possible names for angle ABD. So ABD, let's connect those dots in that order. It looks like they're referring to this angle right here. First option is to actually use that little number that's in the angle. So you could actually call it angle 2 if you wanted to. The other option is, instead of ABD, I could just reverse that and go with DBA. Now, in this case, B is the vertex, but I cannot just call it angle B. Because once again, I'm not sure if I'm referring to this angle, or this angle, or this angle, or this angle. Alright, so angle B is not an option here. Next question wants the vertex for angle 3. So it looks like they're referring to this angle right over here. So if I were to trace it out, it would be this one. And it looks like the vertex would be this point, which would be point C. So I can just name that with a capital C. Next question wants the sides of angle 2. So we're going back to this angle that we had from the first question. Now I want to name the sides. Now remember, the sides are going to be 2 rays that share an endpoint. So they're going to share endpoint B. So it looks like it's going to be BA. Remember, use your symbol for ray. And it's going to be BD. And for the last one, I want to name all the angles at vertex D. So all the angles coming out of this point. So let's start with this one on the left. So you could call that angle 1 if you want to. You could call that angle ADB if you want to, or you could reverse it and say BDA. Or you could go with the angle to the right of that, which would be this one right here. Now, this one doesn't have a number in it, so I can't use just a number to name it, but I could use 3 letters. I could call it BDC, or we could reverse that and say CDB. And the last one I'm going to go with is the large angle that contains both of them. So it's going to be this angle right here. Now, once again, I can't use a number to name it, but I could call it angle ADC or angle CDA. All right, once again, notice that I did not write angle D anywhere because that is not a valid name because I'm not sure what angle I'm referring to. I need to use 3 letters in this case. And notice that in all my names, D is the middle letter because D is the vertex for all those angles. Next, I want to name the 4 different types of angles. So let's go with the smallest one, which is acute. So for this angle, it's going to be a smaller angle. It's any angle measure. I'm going to call my angle measure X. That's between 0 and 90. Can't equal 0, can't equal 90. The next one would be right. All right, so in this case, a right angle, usually we put that little box in there to indicate that it is right. In this case, my angle measure X is going to equal exactly 90. The next one up, bigger than right, is obtuse. So this one obviously opens up a little bit wider. It's greater than 90, but it's definitely less than 180. And for the last one, which isn't too common, but definitely comes up, is a straight angle. So this one's going to be depicted just with a straight line. Now technically there are points on here making it form an angle, but what you need to know about this straight angle is the measure of it is going to equal exactly 180 degrees. Next, we come across the protractor postulate. Now remember, a postulate is a rule in geometry that we accept without proof. So in the picture to the right, we have this angle placed on this protractor. We have side OB, which is a ray OA. Obviously my vertex is at O. The angle I'm focused on is AOB, or in this case you could actually just call it angle O. Now the rays of the form OA can be matched 1-to-1 with the real numbers from 0 to 180. Essentially, I'm saying that if I'm using a protractor, I can measure any angle between these values. The measure of angle O is going to be equal to the absolute value of the difference between the real numbers of ray OA and ray OB. What I mean by that is the values that you see on the protractor. So if I were to focus on the numbers at the top, it looks like this one is pointing to 66. And down here, obviously this one is pointing to 180. So if I want to figure out the measure of my angle, I would take the absolute value of the difference between those two numbers. That would tell me that the measure of my angle is going to equal 114 degrees. Or you could focus on the bottom numbers. So in this case, it looks like I'm referring to 114, and in this case, the bottom number is 0. So it'd be the absolute value of 114 minus 0, which is obviously going to give me 114 degrees. So let's use this picture on the right to figure out the measure of these angles and then classify the angle. By that I mean acute, right, obtuse, or straight. So first one is WSR. So let's connect those dots, WSR. So I'm referring to this angle over here. And let's take a look at the numbers that it's pointing to. So once again, we can use the numbers at the top. Looks like they're going with 65. And down here is 0. So you can plug it into your equation if you want. Obviously, it's going to be the absolute value of 65 minus 0. But I already know that's going to come out to 65. Next one I'm looking at is TSW. TSW. We used this ray earlier. So if I were to use the numbers on top again, this ray is pointing at 65, and this ray down here is pointing at 180. So once again, we can do the absolute value. 65 minus 180 is going to leave me with 115 degrees for this angle right here. Now, notice that the answer for A, WSR, was 65. The answer for B was 115. Well, these two angles together make up angle RST, and we'll eventually get to that concept. And for the next question, they're actually asking about angle RST. You can use that protractor postulate if you want. Compare the values. So obviously the one on top here is 0. The one on top here is 180. But you might just notice that it is a straight angle, so it's going to measure 180 degrees. The last one is asking about angle VST. So once again, S is my vertex. The one side is SV. The other side is ST. You can compare the values if you want. This one's pointing at 90. This one's pointing at 180. You can apply the ruler postulate. The absolute value of the difference between those two is obviously going to give me positive 90 degrees. Last thing I want to do is just go back and classify them. WSR, that one measured 65 degrees, so I knew it was acute. TSW, that one was 115 degrees, so I knew it was obtuse. RST, that one went straight across. It measured 180 degrees, so I knew it was a straight angle. And the last one, VST, was exactly 90, so it was a right angle. Next, we come across the angle addition postulate, which is very similar to the segment addition postulate that we had earlier in the chapter. So I'm referring to this picture on the right where P is in the interior of RST. So P is somewhere inside of this angle. And what I'm saying is that the measure of the large angle, RST, is equal to the sum of the measure of angle RSP and angle PST. So if P is in the interior of angle RST, then the measure of angle RST is going to be equal to the measure of angle RSP plus the measure of angle PST. So essentially, if I want the angle, the measure of the large angle, I'm just going to add up the two smaller angles. For this first example down below, I'm looking for the measure of angle PRS. So obviously that's my larger angle here. And based on the angle addition postulate that I have up above, I know that the measure of angle PRS can be found by taking the measure of angle PRT and adding it to the measure of angle TRS. So now what I'm going to do is replace these with what I know. PRT is 81 degrees. TRS right here is 42 degrees. And if I add those two up, I'm going to get 123 degrees, which is equal to the measure of angle PRS. Now for the next example, let's start off the same way. I have this large angle here, and I know that the measure of angle YXW would be equal to the sum of angle YXZ plus the measure of angle ZXW. So let's fill in what I do have. I actually do know what YXW is. I have this little box here which tells me right away that it is 90. And that's going to be equal to YXZ, which I do have is 26, plus the measure of ZXW. That's what they want you to solve for right here, ZXW or WXZ. So in order to do that, I'm just going to solve it like any algebraic equation, subtractor 26, and it looks like I end up with 64 equals the measure of angle ZXW, or as I said, the same as WXZ. Now, for this next example, they tell me ADC is 135. I want to find the measure of angle BDC. Let's start off the same way. Let's set up the angle addition postulate with the picture they give me on the left. So I know the measure of angle ADC, it's the large angle, would equal the sum of the two smaller angles. So that would be angle ADB, 7x on the left, plus the measure of angle BDC, which is the 11x plus 9 on the right. Let's fill in everything I know. ADC, they gave me that in the directions, 135. Next, ADB, I just pointed that out, is 7x. After that, BDC is 11x plus 9. Now you don't have to include the parentheses here. The reason they did in the picture is because at the end, remember, it's an angle. It has degrees. Take a second, see if you can solve this on your own. I'll reveal the answer in a couple seconds. So x equals 7, and the last thing they want is BDC. So BDC was this angle on the right. Remember that one was 11x plus 9, so I'm going to plug 7 in there and solve for that measurement. So it looks like we have 77 plus 9. So it looks like the measure of angle BDC is going to equal 86 degrees. Now for this next example, they just described to me what's going on. D lies in the interior of angle ABC. So let's start off with a picture. So I'll sketch out an angle. I'm not really sure how large it should be. And let's label it A. B is my vertex, because remember that letter is in the middle. C. Then they go on to tell me, well, D lies somewhere in the interior, whether it's up here or down here or maybe somewhere in the middle. I'm not really sure, but you can just place it wherever you want. Doesn't really matter. All right, then I want to draw out my other ray to complete my angle. So we have D up here, and then we have ray BD. Now they go on and give me more information. ABD is 2x plus 7. So this angle up top is 2x plus 7. Next, they tell me CBD is 3x minus 5. So that's this angle down here. And lastly, they tell me that ABC is 7x minus 8. In order to show that, I'm going to mark this one in a different color. So ABC, remember that's referring to the whole angle. And I'm going to draw a little arrow and say that this angle right here is 7x minus 8. Now that I have my picture, let's start off the same way I did for the previous problem. I know that the measure of angle ABC, according to the angle addition postulate, is going to be equal to the sum of the two smaller angles, which would be the measure of angle ABD plus the measure of angle DBC. Once you have your equation set up, fill in everything you know. ABC, 7x minus 8, the large angle. ABD, 2x minus 7, and DBC, 3x minus 5. Take a second, see if you can solve this equation on your own, and I'll reveal the answer in a couple seconds. It looks like x equals 5, and the last thing they want is the measure of angle ABC. So remember that was 7x minus 8, so I'm going to replace x with 5 and solve for that measurement. So it looks like we end up with 35 minus 8. So the measure of angle ABC is going to equal 27 degrees. The next part of our notes brings us to our next definition, congruent angles. These are angles that have the same measure. So let's say I'm presented with two different angles. Say we have angle A right here. Just going to name it by its vertex, and angle B over here. And let's say both of these measure 40 degrees. Well, in this case, I could say that angle A is congruent to angle B. And in that case, I know that the measure of angle A is equal to the measure of angle B. Now, in order to show that in my pictures, what I would do is I would include a little arc like this that would tell me immediately that these two angles are congruent. Now, let's say in my picture I have other angles as well. Let's say I have angle C off to the right and angle D as well. And let's say these two angles are also congruent to one another. So angle C is congruent to angle D. So they have the same measurement, but they're not the same as angles A and B. So in order to show that those two are the same, what I'm going to do is I'm going to include two little arcs in those angles to show that those two match up to one another. Now, this could continue with 3 arcs, 4 arcs, 5 arcs, as many as you want, depending on how many angles are congruent to one another. Next term is an angle bisector. So remember earlier we talked about a segment bisector. It splits it into two equal parts. So the same idea for an angle, but in this case it's referring to a ray that divides an angle into two congruent, I'm just going to use the symbol here, angles. So if it bisects, it splits it into two congruent angles. So in this picture down below, you can see these little arcs that I showed earlier. Notice it doesn't go all the way across because it's referring to two separate angles. In this picture, it's trying to tell me that angle LKM, so that's the angle on the left over here, is congruent to angle MKN. N, the angle on the right over here. The next example starts off by telling me that ray XZ bisects this angle WXY. So I know right away in my picture that these two angles are going to be congruent. So I can say that angle WXZ is congruent to angle ZXY. And in other words, based on that, I know that their measurements are going to be equal. So I know right away if WXZ is 39, then ZXY must also equal 39. Now, in the directions, what they want is the measure of the two angles that are not given in the diagram. Well, I found the one, but now I want to figure out that larger angle. So the last thing I want is the measure of angle WXY. Well, this one is just going to be the sum of the two smaller angles. So essentially I'm using the angle addition postulate, where I'm saying that WXY is going to be equal to the measure of angle WXZ plus the measure of angle ZXY. Well, once again, I know both of those are 39, so it looks like my larger angle is going to equal 78 degrees. Take a second, try out B on your own, and just take note that the 46 here is referring to this whole entire angle. So that right there is telling me that the measure of WXY equals 146 degrees. I'll reveal the answer in a couple seconds. So in this case, both of my angle measures end up equaling 73 degrees. Because once again, remember that XZ bisects that larger angle. So all I had to do was take that 146 and divide it by 2. For the next example, in the picture below, they tell me that BD bisects angle ABC. So right away, based off that, I know that angle ABD is going to be congruent to angle DBC. So this angle on the left is congruent to this angle on the right, which once again tells me that their angle measures are going to be equal, which will allow me to set up my equation. So on the left we have ADB, which is 8x minus 16. And on the right we have DBC, which is 4x plus 20. So it looks like I end up with 4x equals 36, and in this case x equals 9. And what they want is the measure of angle ABC. So I'm going to take 9 and plug it in for both of these x values. So we end up with 56 on the left-hand side and 56 on the right-hand side, which is what I expected. They should be equal. Then the measure of angle ABC, using the angle addition postulate, I can add up the two smaller angles, which gives me 112. So the measure of angle ABC equals 112. So for this next example, they describe a situation. We have ray BD that bisects angle ABC. So let's just start off with a picture. It'll be similar to the picture I had before. We have a larger angle ABC. B is my vertex, remember, it's listed in the middle of the name of my angle. And then we have ray BD that bisects it. So when I draw point D, I'm going to try to put it somewhere in the middle of my angle. So here's point D. Next, I'm going to label everything I know. Angle ABD is 5x plus 20. So this angle is 5x plus 20. I'm trying to use a little color to indicate that. So the angle in red is 5x plus 20. ABC, which is the larger angle, in blue, is going to be 4x plus 100. And I want to figure out the measure of angle DBC. Well, let's focus on everything I know right now. Let's go back to what I started with bisects. Because it bisects, I know that the measure of angle ABD has to be equal to the measure of angle DBC. So this angle that I marked in red earlier is going to be congruent or equal in measurement to the angle below it. That means I can also write down here 5x plus 20. They're going to be the same. Now let's think about that large angle. The measure of angle ABC is going to be equal to the sum of the smaller angles. So that would include angle ABD plus the measure of angle DBC. So let's fill in what I know. I do know that ABC is 4x plus 100. And that's going to be equal to ABD, which is 5x plus 20, plus DBC, which is another 5x plus 20. Now, take a second, try to go through and solve this, and I'll reveal the answer in a couple seconds. So I've found that x is 10, and remember they want the measure of angle DBC. So let's go back and plug it in for x. The top angle ABD is going to be 70. The angle below that, 70 as well. That's what I expected. And then the larger angle ABC, it looks like, is going to equal 140 degrees. So my final answer for the measure of angle DBC equals 70 degrees.